Welcome! Today we're going to be working on 12B, which is some more functions. Our content objective is students will be able to determine whether one thing is a function of another and define what dependent and independent variables are. Our language objective is students will be able to verbally justify why a situation may or may not be a function. And why am I learning this? Well, it's important for real-world problems like showing the relationship between the number of grams of fat compared to the number of calories from fat. So first things first, let's go over some background knowledge. Let's remind ourselves, when is something a function? Okay, when is a relation a function? So in this case, you know that I like to think of it in terms of, hey, if you block off the output for a second and ask yourself how many outputs for each input, if it's only one, then it is a function. And if not, if it has more than one output per input, then it's not a function. So in this case, since each input has exactly one output, we would say that this is a function, because normally students will look at this 5 and notice there's a lot of arrows pointing at it and they'll automatically think it's no function. But again, if it helps, simply cover up this side and then ask yourself how many outputs are there. Number 2, is it a function? Well, let's see. The input of -3 has an output of -1. The same input of -3 has then an output of 0. So already it doesn't have a unique output, so therefore it's not a function. Here for number 3, is it a function? Well, if you ask yourself, if you were to draw a vertical line, will it touch more than once? And you probably say, no, it doesn't. I mean, yes, it does. It touches in 3 different locations. So this is not a function. And number 4, again, if you want to, you can simply cover one side and ask yourselves, does each input have exactly one output? If you look here, you will notice that the input of -2 has 2 different outputs, and even if I were to reveal, you would see it has an output of 3 and 4, so it's not a function. So remember, in order for a relation to be a function, for each input there has to be exactly one output. Okay, we've done this before. We found the function rule based off of the table. In this case, this one was y equals 3x plus 1. So I would say the function rule is y equals 3x plus 1. If you were to graph it, you can see that the slope is indeed 3. There's a vertical change of 3, horizontal change of 1, and it does touch the y-intercept at 0, 1. Here, if you were to find the function rule based off of a graph, you would have to find the slope and the y-intercept, so you can put in slope-intercept form. So here, slope would be, I would choose these 2 points close to each other, so it's a vertical change of 2 and a horizontal change of 1, so that's 2 over 1, or in this case, you could have chose 4 over 2. And then the y-intercept, well, occurs right here, and I would call this 0, 3, so I would say 3 is B. So my function rule following slope-intercept form would be y equals 2x plus 3. Okay, so now just a friendly reminder, x values are also called inputs. Y values are called outputs. The x values are independent, okay, and the y values, aka outputs, are the dependent variables. Okay, and that's what we're going to be working on. Just a friendly reminder, the output, which we call y, depends on the input, which is x, which is why it is called the dependent variable. So the very formal definition of a function, bear with me for a second, it is kind of lengthy, but just hear it out. It is given 2 variables, x and y, which we're used to hearing. Y is a function of x if there is a rule that determines one unique y value for a given x value. So it's basically saying y is a function of x if y can be determined, and it has to be unique, off of a value that you're given for x. So let's take a look here. If you were to look at number 1, I can write an equation in terms of y, in terms of x to give you y. So here I can say y equals 0, x plus 5, but normally we don't write it like that. We would say just y equals 5. So something is being done to x to give you a unique value of y. Okay, so let's take a look at this example right here for a second. It says, you go fishing and catch 3 fish each hour. So just think for a second. For the first hour, you get 3 fish. For 2 hours, you'll get, you guessed it, 6 fish. For 3 hours, what is it? 9 fish, okay? So, hopefully you got the idea. So here, notice in our graph, I went ahead and labeled the x-axis, the number of hours spent fishing. And just FYI, the x-axis is generally the axis in terms of time, whether it's hours, minutes, years, generally that's what it is. And then here, the y-axis is labeled the number of fish caught. So notice our graph is in scale, so you definitely want to scale it based off of our information that we're given. So here, I'm going to go ahead and say that for 3 hours, you'll get 9 fish. For 2 hours, you'll get 6. For 1 hour, you'll get 3. For 2 hours, of course, we already said 6. It's going to be 6 again. For 0 hours, it's going to be 0 because no hours fishing gives you no fish. And for 4 hours, that's going to give you 12. So looking at my x's, okay, it's ranging anywhere between 0 to 4. So here, I'm just going to go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then in terms of y's, it goes anywhere between 0 to 12. So I think I can afford to also go by 1s here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So at this point, now that I've scaled it, I can kind of plot these points, 3, 9, 2, 6, 1, 3, 0, 0, and 4, 12. Now, based off of what we know about functions, is this a function based off of the graph? Hopefully, you're saying yes. Why? Because it would pass the vertical line test. If you were to draw a line, okay, a vertical line here, it will only touch the graph once. So, I would say the number of fish caught is a function of the number of hours spent fishing. Okay, and just remember, this is a proportional relationship because it's linear and it goes through the origin. So that's why it follows the form of y equals, or calling it mx now. But in 7th grade, you did learn it as y equals kx. Okay. So, again, it is a proportional relationship. Now let's talk about which variables are the dependent variables and which ones are the independent variables. So notice here, we have the number of hours spent fishing and the number of fish caught. Which one depends on the other? Well, I would say the number of fish is determined by how long you fish. So guess what? The number of fish caught is dependent on the number of hours spent fishing. So this is my independent variable and this is my dependent variable. Okay, so just remember that you're looking to see which one depends on the other, because once you figure that out, then you know it's your dependent variable. Okay, so now the next question is, should I connect these points? Let's think. So I want you to think for a second here. If this is 1 hour, okay, in between would be half an hour, right? So just to experiment for a second, I'm going to draw a line just to prove a point here. If I were to draw a line like so, about half an hour is going to give you this many fish, okay? If you remember, we went by 1, so 1, 2, 3, 4, 5. Well, according to this line, if I drew a line in half an hour, I would get about 1.5 fish approximately. Now, let's think for a second. Can I catch 1.5 fish? The answer is no, right? At least I hope. I don't want to catch that kind of fish. But I would say no, okay? So let's talk about some vocabulary words. Discrete relations is basically when the x value is only at distinct points, okay? So for example, the number of students in this class. We can't have half a student. We can't have a third of a student, a fourth, etc. It's a whole student, okay? Continuous relations basically has values for all values of x, okay? All in between. So here, the height of a rocket as it's shot into space. In 1 hour is a certain distance. In an hour and a half is a certain distance. Okay, it's possible to have half a distance. Is it possible to have half a fish, half a student? You'd hope not. Okay, so to answer the question, since the data points, since we don't really count half a fish or a quarter of a fish, we would say it's not connected. Okay, so let's take a look at number 2. Your best friend goes fishing. And here we have some information on how long they went fishing for and how much they caught. So here, looking at the numbers, I can appropriately scale everything. Since this goes from 0 to 5, I'm just going to scale everything by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 15. So in the future, of course, you don't want to scale it on top of your title. It's just, mine's in the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then this should be 15 right here. So I'm going to go ahead and notice X is labeled as the X-axis and Y is labeled as the Y-axis. I'm going to go ahead and plot these points. Now, based off of what you know about a function, okay, would you say this is a function? I hope your answer is no. Okay, and why? If you use the vertical line test, you'll notice right here it touches more than once. In fact, it touches twice. So I would say this is not a function. Okay, so the number of fish caught, which is this, is not a function of the number of hours spent fishing. So notice you always base your y in terms of x. That's not a function. Okay, so let's look at number 3. The table below shows the number of nickels you put into a machine and the number of gumballs you receive. So here, again, looking at the data, I'm going to go ahead and scale it. Seems like everything is under 15, so I'm going to scale everything by ones. So 1, 2, 3, 4, 5. Whoops, that's not a 5. 5, 6, 7, 8, 9, 10. And this should be 15. This should be 5, 6, 7, 8, 9, 10, and then 15 here. Okay, so I'm going to go ahead and graph these ordered. Technically, they're ordered pairs 1, 2. Wait, it says, are the numbers of gumballs you received a function of the number of nickels you put in? In order to answer this question, I'm going to go ahead and graph it, because if I graph it, I can visually see if it passes the vertical line test. Understand there's more than one way to figure that out, but on that note, let's just go ahead and graph it real quick. 1, 2, 3, 6, 5, 10, 2, 4, 4, 8, and 6, 12. So looking at this, is it a function? I'm going to say yes, because no matter where I draw a vertical line, it will only touch once. Therefore, it is a function. Now, could you have thought of other ways to check whether or not it's a function? Definitely. You can map this. Okay. You could check to see that each input has exactly one unique output. Okay. I just like graphing it if I'm given a graph, because I can see it a lot quicker. But again, notice there are other ways of doing it. You know that I'm a big fan of mapping. So here I would do all the numbers from 1 through 6. So 1, 2, 3, 4, 5, 6, and then here I would list all the different outputs I could have used. So 2, 4, 6, 8, 10, 12, and I would map them 1 to 2, 3 to 6, 5 to 10, 2 to 4, 4 to 8, 6 to 12. Each input has exactly one output. And so, is it a function? Yes, because each input has exactly one output. So here, notice I did come up with an equation, if you're wondering how. I notice it is linear and it does go through the origin. So therefore, it's going to be a proportional relationship. So that's why it follows the form y equals mx. Of course, you've heard it in 7th grade as y equals kx, same thing. But at this point, hopefully you start recognizing it as y equals the slope times x. So is this discrete? Well, is it possible to get half a gumball or a quarter of a gumball or anything less than an entire whole gumball? The answer is no. So this is a discrete relation. It's not continuous. Okay, I can't put half a nickel and get something less of a gumball. So I would say this is definitely a discrete relation. Now let's talk about which variables are independent and which ones are dependent. Well, first of all, you have to think of, okay, how many gumballs can you get? That is going to depend on how much money you put into the machine. So I'm going to say the number of gumballs depends on the number of nickels you put in. So therefore, this is your independent variable and this is your dependent variable. Okay. So now, taking a look at number 4. The table below shows the number of nickels your friend puts into a different machine and the number of gumball he received. So same idea here. Looking at the numbers provided, I can definitely scale by 1. So just to speed things up, I'm just going to call this 15 and 15. We'll know that it's scaled by 1. So you're asking yourself, is this a function, the number of gumballs compared to the number of nickels put into the machine? Well, again, the best way to visually see it would be to graph it. So if you were to graph it, this is what it would look like. And you would tell yourself, okay, this definitely fails the vertical line test because it touches definitely more than once. In fact, it touches every single time. So I would say it is not a function. Okay. In fact, because this is a vertical line, notice it does cut through the x-axis at 1, hence the equation x equals 1. Again, you could have mapped this if you wanted to. You can see the different outputs, different inputs were 1. The different outputs were 1, 2, 3, 4, 5, and 6. And then you would map it 1 to 1, 1 to 4, 1 to 2, 1 to 5, 1 to 3, and 1 to 6. You'll notice that the number 1 has definitely more than one output. So here you can also clearly see that it is not a function. Okay, so take a look at this one. So notice we're given a lot of information here. We have a graph. We're given an empty table if you want to use it. And we're asked, is the number of chocolate chips a function of the diameter of the cookie? Use the table if needed. Personally for me, I don't need a table. I can clearly see from the graph that in multiple areas, okay, one being here, another being here, it definitely does not pass the vertical line test. In fact, it fails every vertical line test in this case. So I would say it's not a function because each input doesn't have exactly one output. So let me give you an example. The input of 3 is giving you 5. The input of 3 is also giving you 6. And the input of 3 is also giving you 8. It's not a unique output. So I would say this is not a function. Okay? Why? Because each input doesn't have exactly one output. It says here, the number of tires Y in the parking lot at Chris's cars is modeled by the equation Y equals 4x, where x represents the number of cars in the lot. So they went ahead and labeled the number of motor vehicles as x and the number of tires as y. Okay, the question is, are the number of tires in the lot a function of the number of the motor vehicles in the lot? To use a table or graph if needed. Okay, so I'm going to kind of use both so I can show you. If I had 0 cars, I would have 0 tires. If I had one car should hopefully have 4 tires. 2 cars should have 8 tires. 3 cars should have 12 tires. And 4 cars should have 16 tires. So here I can go ahead and graph and say 0, 0, 1, 4, 3, 8, 1, 4, 2, 8, 3, 12, and 4, 16 doesn't fit, so I'm just going to leave it off. Obviously, I scaled these by 1, so I'm going to go ahead and say it goes up to 15 here. So looking at this, can I tell whether or not it's a function? Absolutely. Looking at my graph, I can see that a vertical line would only touch this graph once every single time, so I would say it's a function. Also, if I wanted to, you could map it and say different inputs were 0, 1, 2, 3, 4. The different outputs were 0, 4, 8, 12, 16. Notice whenever you're mapping, you always want one of each number, okay? Just like in that last example, the input was 1 over and over, but I didn't repeat a bunch of ones. I only wrote it once, okay? So that way when you map it, you can see that each input has exactly one output. Okay, so definitely I would say the number of tires is a function in comparison to the number of cars. Okay, so at this point, I would like you to go ahead and try and pause the video and see how well you do on this one by yourself. Okay, so it says the cost of cars entering a toll booth is based on how many passengers are found in the car and is listed in the table below. So here they gave us the number of passengers and the amount per car. So I am going to go ahead and scale my x by 1s because it will definitely fit. Here the numbers are slightly bigger, so I'm going to go ahead and scale it by 2. So I'm saying 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20, 22, 24, 26. Oh, I'm not consistent there. Let's try that again. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. There you go. So I'm going to go ahead and graph this because they're going to be asking me, is it a function? Is the amount of per car a function to the number of passengers in the car? So I'm going to say 1, 5. So 2, 4, 5 is going to be in between. 2, 9. So 2, 9. 3, 13. 10, 11, 12, 13. 4, 17. Let's see. 2, 4, 6. 7 and 5, 21. Okay, so by the looks of this, I am definitely going to say based off of the graph, it's going to be a function because the vertical line will only touch this graph once every single time. Again, you could have also graphed it, mapped it and said 1, 2, 3, 4, 5, and again, notice I only write the numbers once. Here I'm just going to write the numbers that I need, so 5, 9, 13, 17, 21. And again, once again, I didn't write any of these numbers more than once. I will map them. I did a horrible job doing that. Map them and notice that each input has exactly one output. So therefore, I would say it is a function. The amount of per car is a function to the number of passengers in the car. Okay, so now let's talk about independent and dependent variables. So for each function below, define the independent variable and the dependent variable. So for number 8, it says the math club is selling tickets to the math Super Bowl. The more tickets they sell increases the amount of money they can spend on beverages and food. So what depends on the other? Does the tickets depend on the beverages and the food, or the beverages and the food depend on the ticket? Well, hopefully you said the beverages and the food depend on the ticket, depend on how many tickets are sold. So I would say money earned depends on the number of tickets sold. Okay, because that's the money. Number 9, the number of calories you burn increases as the number of minutes you walk increases. So does the calories that you burn depend on how long you walk? Or does the amount of minutes that you walk depend on how many calories you burn? Hopefully you're able to tell me that. The calories that you burn, it's dependent on how long you walk. Okay. And number 10, as the amount of rain decreases, so does the water level of the river. So does the amount of rain depend on the water level of the river? Or does the water level of the river depend on the amount of rain? Hopefully you said the level of the river depends on the amount of rain. Okay, so you gotta logically figure out what depends on the other. So that is going to conclude our lesson for today. Thank you so much for tuning in, and as always, until next time, bye.